This problem is introducing us to capacitance. We are given a small capacitance right here in microfarads, and then we are told the capacitor has a constant current of 109.9 amps through it for a short while. We were asked what is the change in voltage per microsecond during this period. We are going to use this formula that can be found in the notes linked below in section 6.2, the capacitor. So we're going to plug in the things that we know. For our current right here, I of C, we have 109.9 amps. And for our C, which is the capacitance, we have 25 microfarads. And it's important to keep in mind that 1 micro is equal to 10 to the negative 6. We are going to rewrite this equation so it suits our needs. We know we want to find dV over dt. It's written right here. So we're going to have dV over dt is equal to IC divided by C. We're simply rewriting the equation. And now we're going to plug in our values. And this is what we're going to get for our answer. We want this in volts per microsecond. Currently it's in volts per second. To make it in volts per microsecond, we're going to have to multiply this by 10 to the negative 6 over 1 micro. That way we can get 1 micro in the bottom. And multiplying it by 10 to the negative 6, we're going to move the decimal place 6 places to the left. And this is going to let us know that dV over dt is equal to 4.4 volts per microseconds. And that is the answer and how to go about looking at a simple capacitance problem. If you want more capacitance, inductance, or any intro to circuit analysis problems, there's a playlist in the description below as well as notes that's for all of this coursework. If you have any questions about the material covered here or in any other videos, you can leave them in the comments as well.